this is Calculus 12, Chapter 2.2. We're going to be looking at the precise definition of a limit for those who are interested or for those who need to know. Let C and L be real numbers. That means it's finite. The function has a limit L as x approaches C if given any positive number delta, such that for all x, we have this. This needs to be corrected because the book is a little bit wrong. Remember, the limit is not concerned about the value at C. It's only near C, so x does not equal C. And we can see that this condition has to be greater than 0. So if it was C, C minus C equals 0, which doesn't satisfy this. Okay, so if we have x minus C is between 0 and delta, then we have f of x minus L is less than epsilon. Then we can write the limit as x approaches C of f of x equals L. Okay, so when we use this, we need to substitute. So here's an example. So what we're trying to do is find delta in terms of epsilon. That way we don't have two variables to deal with. We just have one, and then the whole statement is proven. So we're going to prove limit as x approaches -2 of 2x plus 1 equals -3. So again, we need to find in terms of epsilon. So find x minus -2 absolute value is less than delta when the absolute value of 2x plus 1 plus 3 is less than epsilon. Okay, so this really is minus -3, which becomes plus 3. Okay, so we take this, we simplify this, and we need to make it look like this. So what we need to do is factor this one. So we factor this out, and x plus 2 can be rewritten as x minus -2. We bring the 2 over to the other side. So this tells us delta is epsilon over 2. So the proof, we use the definition. We let epsilon be greater than 0 be given. Then we have this. So we just go back to our statement. And we just show our work here. So we have the 2x plus 4, absolute value, factor out the 2. And this should not be here, so we'll cross that out. 2 times the absolute value of x plus 2 is less than 2 delta. Okay? Because we said delta equals epsilon over 2, so epsilon equals 2 delta. We substitute our delta with this. We've shown that this side is less than epsilon. Okay, so now we can just restate it. If we take delta is equal to epsilon over 2, and we have x minus -2 is between 0 and delta, then we have the limit as x approaches -2 of 2x plus 1 equals -3. So graphically, what does this look like? This is our 2x plus 1. Okay, and here we have -2, -3. -2. This is the origin. This is our -3, this is our L, this is our C. So here we have our delta and our minus delta. We cross over here, we have epsilon, cross over here, we have minus epsilon. Okay, so we have L plus epsilon, L minus epsilon. We have C plus delta, C minus delta. And this is epsilon over 2. This is minus epsilon over 2. So that's what it looks like graphically. So whenever we're less than delta, we're always going to be less than epsilon. And that's the definition of the limit. And we don't care about the value at C because that could be undefined. And that completes this lesson.